Hello. Hello.
Hello.
Yes, sir.
Hello,
Audible
ma'am.
you.
Sir, I have not received new meeting link yet. Could you please share it?
It's been so long that we all are waiting like this.
I think we should respond them on LinkedIn on the same link.
Is there
Think
anyone from the organizer side here?
I think they
Please
all are
respond.
absent. I think they all are absent, and in their poster they have mobile number, so I think we should call on that number only. 63. I'm sharing the number on chat. 63 0006 4097.
our voice become
The organizers are busy right now. They are don't picking a call.
On YouTube, they are streaming the same thing. It's not working yet, then how can it work then?
Hello, sir. Not audible.
But of polar orbital satellites, they are all GPS satellites, GNSS. They are the GPS satellites, and they also measure the total water content in the atmosphere, and some of other parameters like aerosols, carbon dioxide, and trace gases, greenhouse gases, etc. And they measure gravity information, groundwater, surface water information, and other mix of there. These are all polar orbital satellites, and from them we are getting about 9,39,748 information. See how much within that vertical profiles are only 3,884. So manual vertical profiles are there about 5,000 of them, and from satellites we are getting vertical profiles about 3,884, and remaining thing are integrated value of the atmosphere, and they are all satellites. So this is a daily variation of satellites, different satellite data for 45 days. Now different kind of satellite. This is a scatterometer. Scatterometer means this is again a polar orbital satellite. It will measure the wind vectors on the ocean surface. So this much area of the ocean is collected in the evening of yesterday to get the wind vectors over the ocean, but still there are gaps. So some effort is made to receive. So here 7,95,000 observations are coming, wind vectors at a particular point of time. Yesterday's 12 UTC means evening 5:30. So much data is received. And subsequently, now this is the biggest one. From all the geostationary satellites, we talked about 6 geostationary satellites, or Pacific, Atlantic, Africa, Indian Ocean, Indian Ocean by INSAT, and this INSAT 3DS, INSAT 3D are there, and rest all are other countries' geostationary satellites. You see here for winds, atmospheric wind, atmospheric motion vectors, wind at different levels, 3 levels, 4 levels, it is generated. So there we are getting 31 lakhs observations. So imagine these geostationary satellites continuously every 15 minutes you have this data. So you can imagine each satellite is giving, India is giving 1 lakh 15, and INSAT 3D are giving 63,000, and this Meteosat 10 is giving 2 lakhs. So like that, different satellites put together is about 31 lakhs wind vectors at 3 different levels in the atmosphere is done. Then that is by visible all put together. If you separate this infrared uh, uh, sensor of the satellites generating wind vectors are about 17 lakhs out of that. So remaining 20 lakhs are from visible sector, visible sensor of the geostationary satellites. So the visible sensor is covering this much area, and infrared sensor is covering the whole area. And different sensors. This is a water vapor sensor. It is in the much upper level, higher level. There again, 6,91,000 parameters observations we are getting. So average of similarly, they are all geostationary satellites we have seen now. This is atmospheric motion vectors from the polar orbital satellites. Polar orbital satellites are also giving about 31 lakh observations. So they are giving over the poles. Other satellites are not covering the pole area. So that's a mix of geostationary, mix of polar orbital satellites will cover the whole globe on a continuous basis. So wherever manual observations are not there, so this is compensated by these observations. So on different projections, polar on the North Pole, South Pole also it is there. So apart from directly derived products of wind vectors, vertical profiles, etc., here radiance is also measured by the satellite. Top of the atmosphere, the radiance. by the different satellites. So from the radiance data, we can radiative transfer principles, we can generate the vertical profiles of temperature and humidity from top of the atmosphere to the ground. So there is a radiative transfer physics, so that is used to generate. Apart from direct measurements of winds at different levels of the atmosphere by visible range measurements, infrared range measurements, and water vapor range measurements by the satellites. They're all wind vectors. And polar orbital satellite scatterometer will give at the surface. When you mix geostationary and polar, you get directly measurements. About 60 lakh we are getting there. Now we are getting radiance, this radiance data through using radiative transfer in the data assimilation system. You can generate the vertical profiles of moisture and humidity the way these manual observations were collecting. So here the manual observations are there. I'll just show for your complete understanding. So these are the manual observations of vertical profiles of wind, temperature, and humidity collected from the different observatories by manual effort. This is collected. Here about we are getting 2690 only. So afterwards you are getting from the satellites lakhs and lakhs. This is 9 lakh here and about 7,95,000 of scatterometer winds and 31 lakhs of cloud motion vectors and another 31 lakhs of polar orbital satellites of the wind vectors, vertical wind vectors. This is the polar distribution. So that much data is going, and apart from that, then radiance will generate the vertical profiles. So now wherever manual observations are not possible over the sea, in all those ocean sectors, these radiance measurements, these are called sounders. Earlier, wind vectors and cloud images are carried out, generated by imager on the satellite. So there are two payloads. One is imager, another one is sounder. The sounder is measuring the radiance in different frequencies of water vapor, ozone, carbon dioxide, which is there in the atmosphere. So different gases have different absorption and scattering characteristics. So that is a radiative transfer mechanism. So vertically, wherever their distribution is there, so temperature and humidity are modified, moisture are modified vertically at different levels. So that is an exact physics. So using radiances, those vertical profiles are generated. So this is satellite radiance from other polar orbital satellites at that point of time, apart from geostationary satellites. So you can see a total number of other profiles of radiances from other polar orbital satellites. This about 14 lakhs. So much of observations are getting corrected. This is by SSMI, is the Defense Military Space Program of USA. So they are giving another 8 lakhs satellites data of vertical profiles, and GPM it is the rainfall measuring mission, that is also giving about 4 lakhs. So you can see so much of observations are becoming available. These are polar orbital satellites of NOAA. They also have radiances. They are giving about 15 lakhs. So about more than 1 to 2 crore observations are getting collected from different sources on a particular day. And if you see how much data is going into the assimilation of the describing the actual structure of the atmosphere before the forecasting is start. It is called data assimilation. That's where the satellite data is going into. We are getting about low Earth satellites or GNSS satellites, where about uh, 18 low Earth satellites are there. They are about less than 500-kilometer height. The polar orbital satellites, they are put. They don't cover the pole. East-west only. That low orbit satellites, they don't cover from North Pole to South Pole. So these are called low orbit satellites. We are receiving data from about 18 low orbit satellites. You have seen their numbers, so you can also see here 10 to the power 5, 10 to the power 5, 10 to the power 5, 10 to the power 5 on different dates. Data is received. And geostationary satellites, 6 geostationary satellites data is received. And numbers we have seen just now. And this is how this much polar orbital and geostationary satellites data is received, and the radiance data, how it is utilized, is available from this analysis. So if you see amount of data which is received, so total data is received from NOAA is about 150 GB, India is about 53, INSAT, Doppler weather radar 32, from Korean satellite 100 GB, Chinese satellite CMA about 19 GB, from ISRO other satellite data is about 0.5 GB. This is from Europe, 108 GB, and JMA 8 GB. So you can imagine manual observations is just 1 GB. So you can see how much data is coming, and all that goes for assimilation. So these are the radiance uh, measurement from so many satellites on top of the atmosphere, and where radiative transfer is used to generate the atmosphere. So this is how different group of satellites cover at a particular time. And this data, this is more important. You are collecting millions of millions and tens of millions of data. So observational data received. And after quality control, this blue color goes for data assimilation system. And this green is the actual data accepted by the modeling assimilation system. So you can imagine out of this much collected, this much is after quality control is pushed into the data assimilation system for describing the most representative three-dimensional structure of the atmosphere. And out of that, another 20% is rejected by the data assimilation system because it is not consistent with the model atmosphere. So whatever is not, so you can see out of the total data received, about 70%, roughly 60 to 70% goes into the modeling system to describe the atmosphere and to generate the forecast for next 10 days. So here you can see different satellites. That is an integrated satellites, and IIAC METOP. These satellites, if you see, this has got full quantum acceptance. IIAC METOP A and IIAC METOP B, and then CRIS has next relatively higher amount of data acceptance by the system. Very poor is AMSR, where this much data is received, this much data was accepted after quality control, and not much is going for assimilation at all. So there is no green line here. So this is what is the feedback continuously given to the satellite data generation agencies like our Indian Space Research Organization ISRO, and UMET European Space Agency, and Japan Space Agency, Korean Space Agency, like that. So to all data generating agencies, satellite operational agencies. So this feedback is given where the data is good and it is accepted, where data is not good and it is not accepted. So you can clearly see a lot of difference in actual usage of satellite data and by the forecasting system, and that's how this data becomes very, very important. So you can percentage of satellite radiance data getting accepted. So IRC, as I told, 49% of that data received, millions is received. Out of that, roughly 50% is getting accepted. But next best is the 16. This is the CRIS. I shown on the plot also. And next best is 13. This AMSU. And another blue is EIRS. So these are the different sensor payloads on board of different geostationary satellites. And so if you can see here, 759 million observations are received. So out of that, this much got accepted. So on this, on the average of month, so this is July 2020, for example, I have taken. In that month, 759 million observation points are received. Out of that, 49% by this, 13% by this, 20% by this. So that's how. But still, they are very important for our forecasting purposes, modeling purposes. So these are the different types of satellite data which is used and pushed into the data assimilation system for generating forecasts. And then if you see here, so if you see how much data we have seen now, the atmospheric wind vectors, temperature, humidity, which are required for the model. So on the other hand, we have satellites measuring these aerosol concentrations, aerosol density, mass. This is distribution and ozone, and from the top of the atmosphere and the surface, and carbon monoxide and nitrogen dioxide, NOx from different satellites are also collected. And then we have some Copernicus atmospheric modeling system run by the European Space Commission, by the European Center for Medium Range Weather Forecast. So using all the satellite data, black carbon emissions are generated globally as a baseline information for prediction of air quality and concentrations of greenhouse gases across the globe in next 5 days or so at 25-kilometer grid scale. For generating this with all available satellite data, this anthropogenic black carbon emissions is generated. This is one particular data, and another this is about carbon dioxide concentration. So this is about methane distribution. And this is NOx, nitrogen dioxide, NOx, NOx, and this is about benzene. These are all greenhouse gases measurements. This is black carbon measured by the transport sectors, by the vehicles in different parts of the globe manually. These are all manual measurements. Earlier ones are satellite measurements. And this is NOx from measured from the aircrafts. You have seen wind temperature, humidity received from the aircrafts also, from this NOx also measured, collected from the aircrafts. This is from the ships, collected from the ships. So you can see how much effort goes into the system. So you can clearly see nitrogen oxide emissions from the this below one is from the satellite. This is generated baseline information by the Copernicus atmospheric modeling service. So you can see how closely they compare. All the peaks are captured. This is instant measurement by the Sentinel satellite. And then this is the analyzed satellite by taking all the data from the shapes, aircrafts, satellite, long-term satellite data put together. So that's how the accuracy and representativeness of the data is collected. And I'll show some more other yeah, from this much only, from greenhouse gases and other satellites, other information from the satellite and used for prediction, apart from the weather parameters. So we have seen this, and then so here another important thing is about the sea level rise measured from the satellite. So this is from NASA satellite, and it is measured by a sensor called altimeter, and you have continuous measurement of sea level changes from 1993 to 2024. It is the latest update which is available now. So 2025 updation will happen because a lot of data collected, processed, and added anomalies are generated. So you can see very clearly how the sea level rise is there between change in the sea level. So it is wherever suppose this blue color is there, sea level has gone down, whereas rest of the areas from yellow to red, sea level has gone up. So over our Arabian Sea, Bay of Bengal, Indian Ocean, North Indian Ocean, north of equator, it is minimal so far. Whereas over the South Indian Ocean, Madagascar, the sea level rise is relatively high. In polar latitudes, it is much more higher. Similarly, North Pacific and North Atlantic, whole of Pacific, North Pacific, South Pacific, Atlantic, South Atlantic, sea level rise is quite high. Whereas relatively compared to other regions, there are some pockets where sea level is also negative, gone down. So this is the area which we are worried about. About 11 centimeter sea level rise has happened from 1993. This is purely from satellite altimetry measurements. These anomalies are measured, particularly in our Bay Islands. Andaman side, sea level rise is relatively high compared to our Lakshadweep and the Maldives. And the north part of Bay of Bengal and the southern part of southwestern part of Bay of Bengal, it is less, rise is less. Similarly, over several parts of open Arabian Sea, sea level rise is less. So this is about the sea level rise, how much different sensors are giving us the data. So another interesting thing is water level measurements in the lakes and reservoirs globally. So this is very, very important. Satellites measure depending upon their polar orbital coverage. In last 10 days, different lakes globally are water levels are measured. Suppose so Lake Gandhi, I have clicked, so it is showing some gap is there because satellite has to pass over that lake, then only you can get the water level measured. And past 3 years, how water level has changed. So all this information becomes available depending upon the satellite coverage. So every 10 days, this kind of information, and it gives this color also tells above average or below average water levels. So these are all yellow, brown, and red are the areas where below average. 1 sigma, 2 sigma water levels are below average storage levels, whereas blue are above average storage levels. So many parts of India, for example, many parts of India, even now, several of them are in blue colors. So that means many of the reservoirs are currently having above normal storage. So this was measured on 11th March status as on 11th March 2026, very latest, just 2 days before. So satellites generate so much of information. This is a very useful information. Uh, that is 10-day storage levels, and these are monthly storage levels. These are very important. Suppose they are very important in that particular fashion. For example, sharing water from Indian side to Pakistan or Nepal side to India. If you know that the reservoir after release, water will come to our UP side, for example. So this side water level is below average. So there is no question of any releases suddenly coming from the upstream areas. So this measurement will help you to monitor where the upstream catchment area reservoirs are getting full, and sudden releases can be expected from that side. So for that information, where you don't have data exchange mechanisms in real time between the countries, between the transboundary of river management authorities, so you can get some idea from these satellites derived information. So much of data is available from the satellites. So you can imagine, I just wanted to give the whole gamut of satellite measurements, not only for river water management, sea level rise, ocean heat content. There are so many other ocean parameters are also there, chlorophyll measurement, several things are there. So I've covered a bit of overview of current level of satellite sensor potential for our extreme weather prediction for weather and climate, and as well as for river reservoir management, catchment area water levels, etc. And then more importantly, sea level rise and several other ocean parameters are there, which I have not shown today. Thank you very much.
Sir, thank you very much, sir. Thank you very much for your insightful lecture, sir.
Mm.
Sir, anyone have any doubts, means you can ask the sir. Sir will clarify.
Yeah, I'll share the materials, whatever I have showed. I will all PDFs I'll share. Links also I'll share. As mentioned in the chat, I'll share all that. All the PDFs and the links also I will share.
Okay, sir. Okay, sir. We will share it in WhatsApp groups.
WhatsApp group. Thank you very much. All the very best to you.
Thank you, sir. Thank you very much, sir. Thank you.
Wonderful.
Thank you, one and all, for participating. Thank you. We can leave now.
Thank you. Thank you.